Lab 1, Constant Velocity. The goal of the lab was to take an object moving at constant velocity that does not change direction and compare the observed position path with the computer-predicted position path. This lab relates to Newton's second law, which states that an object's acceleration is dependent on the net forces acted upon it and its mass. Using this equation, we can conclude that when velocity is constant, the net force acting on an object is zero, since the final and initial velocities are the same, while the mass and change in time are non-zero. These are the dimensions of the can I was using, which had a diameter of 0.0762 meters and a mass of 0.443 kilograms. Using the tracker program, I first set up the XY axes in the center of the can. As you can see, my can will be moving in the negative X direction starting at the origin. Then, I got my calibration stick in order to calibrate the actual length of the roll. I measured the diameter of the can, then using this tool, I stated that it is 0.0762 meters long. As you can see here, I tracked the center of the can as it rolled along the floor in the negative X direction as I previously mentioned. Because of this, the position versus time plot here is a downward sloping line, and my X values are all negative. The time of the first point is at 0.033 seconds and at negative 2.02 meters. The last point was at 0.967 seconds and negative 0.564 meters. Using the data I collected in Tracker, I then calculated the velocity with the velocity equals change in position over change in time equation. As you can see, because the can was moving in the negative X direction, the velocity is negative. Now I can use this velocity in GlowScript to create the computational model. Now, in GlowScript, I opened the starter code and went through to make some changes for my experiment. I updated the object's mass and set the initial conditions, position, and velocity vectors. I then set where the clock starts and the change in each step to be the same as it was in Tracker. Then I made sure the while loop knew to stop running when the time is less than 0.967 seconds, as it was in Tracker. With all of these conditions set, I ran the program, and as you can see, the ball is moving in the negative X direction, and the plot looks very similar to the one I had in Tracker. Now I can take this predicted data and compare it to my observed data using a double line graph. Using Google Sheets, I created a position versus time plot. The blue line is the observed position, and the red line is the predicted model position. As you can see, the lines overlap very well, showing that the predicted and observed positions both have similar slope, meaning the constant velocities of the two would be about the same, and both would have an acceleration of zero. The question arises of how my results would have changed if I had either changed the orientation of my axes or rolled the can in the positive X direction. If I had done either of these things, my velocity would have been the same, except it would have been positive and resulted in an upward sloping graph. In regard to the number of pushes and pulls being applied to the can, we do not know the exact number beyond the force of gravity and the normal force. However, according to Newton's third law, every action has an equal and opposite reaction, so we do know that an equal number of pushes and pulls takes place in order to result in a net force of zero and a constant velocity. Thank you for taking the time to watch my video.